4-6 and 4-7 estimating square roots and real numbers. I can estimate square roots and find real numbers.
All right, to clarify, thank you, Rathika. 4-6 focuses on estimating square roots, which we also did back in 4-5. And then 4-7 focuses on real numbers. Okay, so the vocab. The vocab, if you recall, only focuses on the real numbers. There is really no vocab for estimating square roots. So a real number would be all of the rational and irrationals. We're going to get to a chart a little bit later that shows you. Rational numbers terminate or repeat, and irrationals never end and they repeat. So number 2, estimating square roots. Very important that you understand what this sign means. A squiggly equal sign means what, everybody?
Approximately.
Okay, cool. And number 3, if you have the negative square root of 39, what do we do with that negative sign? What was the strategy we used in our last set of notes to help us deal with finding the answer on something that has a negative in front of the square root? Jeffrey, what do we do? You ignored it until the end, right? So we just wanted to find what 2 numbers would the square root of 39 be between. 6 squared is 36, 7 squared is 49, so it would be 6 and 7. But don't forget that we're asking for the negative of those numbers, right? Yes, no? And then this would be an approximation. Approximation, so the squiggly equals. Number 4, I'm not going to go through this entire problem with you, but it asks us to get to the nearest whole number. Is that right? To the nearest inch, so the nearest whole number. The tablecloth, or the fringe of the tablecloth length, it was 22 inches. So the nearest whole number is 22 inches. Is that an approximation or an exact answer?
Exactly.
It's an exact answer because we're asking you to go to the nearest inch. Even though it's not truly the total length of the side, I asked you for the nearest inch, or the nearest whole inch. So therefore, that is the exact answer you're looking for. So you may not use approximation on that one. Skipping down to number 3, this is a super important diagram that's not all that complex if you really, really look at it. Real numbers involve rationals and irrationals, boys. Real numbers involve rationals and irrationals, and then rationals have integers and wholes within them. The cheat sheet idea is key. Little box to big box means always. So a little box, whole number, is always an integer, right? An integer is always a rational, right? A rational is always a real, right? An irrational is always a real, right? Good. Big box to little box equals sometime. So if we go from the real numbers down to rationals, are real numbers sometimes rationals? Yes. Are rationals sometimes integers? Are integers sometimes wholes? Yes. So whichever way you're going, you have different terminology. Number 4, classifying real numbers just based upon what you understand that they all are in terms of irrational, rational, real, whole, and integer. And number 5, the density property. The cheat sheet idea basically sums it up. You can always, 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 always fit a real number between 2 other real numbers. Can you always, always, always fit a number between 2 numbers?
No.
Not always, right? Can you fit a number, or can you fit a whole number between the numbers 2 and 3? No. Can you fit a real number between the numbers 2 and 3?
Yes.
Totally can do that. So be careful on your wording when it comes to real numbers and the density property. It must include the term real numbers. Questions?